Yeah, hi, Professor. TA and the class of 5810, section 001. Today, I'm recording this video for the reading assignment 9, and I choose knowledge discovery from large amounts of social media data. Coming to the summary, social media data analysis has been relevant these days to extract meaningful information, to understand people's interactions and behaviors. So this is the common thing nowadays where everyone are doing the analysis, and this would also mean that this information can be further used to understand the group of people's behavior during global events, find out the main topics of discussion, track the people's opinion, and frequent routes followed by the user individually. So this data analysis can be observed in several fields such as sociology, linguistic politics, and computer science. These are three applications that would there are three applications that would help in opinion and pattern mining of social media data. Automatic application for detecting user mobility patterns, a novel application to estimate the political polarization of people opinions, applications to find out the main topic discussion using a hashtag recommendation system. So this is the summary. Coming to the critical analysis from the author, like a large amount of social media data are generated daily on social media platforms. Social media data analysis has been quite relevant to understand the behaviors, patterns, activities, and opinion of users. By critical analysis, the posts that were put on social media. To study social media data, researchers have developed applications that are based on advanced algorithms to get accurate results. Social media data analysis can be carried out based on three different perspectives mainly. Posts created by tourists when they visit a city to discover the tourist attractions, the mobility patterns, opinion of peoples on the electoral events, and also predict the outcome. And the third one is the frequently used hashtags to unveil main topic of discussions and how users use these hashtags while creating the online content. There are three different applications used for social media data analysis. First one is trajectory mining, second one is opinion mining, and third one is topic discovery. Metadata model for social media data. Like one of the major challenges is that we need a standard model to represent and integrate the social media data coming from various sources. For this problem, the metadata model has come into existence. This model is divided into two sections to analyze each social media item: post, photo, video, etc. The two sections are basic section and extra section. Coming to the basic section, it contains the main descriptive field, which are date and time, location coordinate, source, user information, and item ID. Coming to the extra section, it contains the specific fields that would depend on the social media item source. Pasoda. Like the three applications are executed parallelly and are hosted in a cloud platform called Pasoda, like parallel social data analysis. It is a library that helps developers to create a cloud-based parallel applications to analyze a large amount of social media data. It has different packages to detect the different type of information such as user mobility patterns, topic trends, and public opinion. It is based on two frameworks, which are Apache Spark and Apache Hadoop. The main aim of Pasoda is to help programmers to easily extract meaningful information with ease. The library allows defining the social media data analysis applications to perform general 7 steps: data acquisition, data filtering, data mapping, data partitioning, data reduction, data analysis, and data visualization. These are all the 7 steps, and each step Pasoda has a predefined set of functions. It also helps in transforming the data from one format to another and cluster data as well. Advantages of Pasoda: like with Pasoda, programmers can save hundreds of lines of code in the main part, as they need to configure the functions using the function logic or use built in functions. The execution is faster and parallelization has become easier at each step. It helps programmers to easily analyze complex social media data. Social media data analysis applications. To analyze large amount of data gathering from social media, the three social media applications are used from three different perspectives. Trajectory mining from social media data. Awesome. An algorithm used to identify the user mobility patterns for the post published on social media by the users by the means of point of interest, POIs. situated in a geographical location. POIs are the tourist attractions, places such as monuments, bridges, airports, train stations, shopping malls, etc. The term trajectory means the sequence of locations visited by the people. To represent the boundaries of POIs, the region of interest ROIs has come into place. To capture the frequent trajections from a combined set of geotagged items from social media platforms, the following steps are performed. They are as follows. This is the social media data. Keyword extraction will be done in the first step, ROI detection will be the second step, and trajectory mining would be the third step, and frequent trajectories would be done. So this is how the social media platforms, the following steps are performed to capture the frequent trajectories. And the keyword extraction, it is used to identify the important keywords used by social media users to identify the POIs. These identified keywords were used to further groups that the post concerning the place. ROI detection, it is used for extracting the region of interest from the combined post created using keywords in the previous steps. These ROIs are later located on the map. Trajectory mapping, to identify the trajectory across the ROIs for each user. Later, using this information, obtain the frequent trajectories. Use case, a data set of 3 million geotagged items were collected from Rome and Paris from 2006 to 2020. Some algorithm outperformed other algorithms by reaching on F1 score of 0.85 in Rome and 0.87 in Paris, and has been the most accurate technique to find the trajectories of the data set. Opinion mining from social media data. Opinion mining is nothing but iterative opinion mining using neural networks. IOMNM is a data-driven technique that uses feed-forward neural networks to predict the political polarization of social media people during electrolyte events. IOMNM is an open source and easily accessible to users for implementation. Opinion mining is comprised of 3 steps. They are as follows. First one, social media data, like keyword definition is the first step. Coming to the classification of posts is the second step. And third step is the polarization of users. This is the political polarization. Coming to the keyword definition, a set of keywords are gathered from the political events to analyze it from the social media platforms. Classification of posts, there is an iterative method that is based on feed-forward neural networks, which is laterally used to classify the post to specific political parties. Polarization of users, the classification posts created for each faction are used to calculate the political orientation of the users. Coming to the use cases, the data was considered from the 2016 US presidential election across 10 states with where there was political uncertainty. The IOMNM showed a great accuracy, which correctly identified the winning of candidates in 8 out of 10 states compared to the real results of the polling by using the information created by the social media users. Topic discovery from social media data. Topic discovery has the hashtag recommendation model, which uses the hashtags. Sentence to hashtag embedding a translation algorithm that suggests that per set of hashtags for a given post. It uses the modern techniques for natural language processing, and these hashtags are used to label the post and later in turn link them to the trending topics. Opinion mining comprised of 3 steps. These are as follows: semantic mapping, hashtag recommendation, topic discovery. These are all the trending topics. Semantic mapping is created between 2 semantic spaces, which can be obtained from the embedding of sentences, words, or hashtags. With the hashtag model, it can learn on its own to link the given post to the hashtag it contains. Hashtag recommendation. In this phase, it recommends hashtag to social media users wherever a user and embedded vector is computed, and it is projected in the hashtag space, and a semantic process is performed to maximize the hit rate of the hashtag recommendation systems. Topic discovery. All the main topics in the hashtag embedding space are divided into different clusters of similar hashtag. To achieve good visualization, the dimensionality is reduced to 2D. It uses principal component analysis. Topics optics are used for identify the micro topics in social media conversation. Use case: the tweets data to identify the topic during the COVID-19 pandemic. Use the recommendation ability of hashtags. The discussion topics were extracted from a set of data sets, which were the online conversation about the health emergency. Many models were used by the hashtag model, gave accuracy of 0.77. Results. The 3 different applications used to extract meaningful information from the 3 different perspectives were understood using the various causes, and the results obtained significantly the valuable knowledge that can be extracted using parallel computing approaches. Coming to the conclusion, there is a lot of future work that needs to be done in the area where social media data is unreliable. New techniques have to come to select reliable data. New algorithms and techniques should be improved to differentiate between the posts created by humans and the posts created by the bots. It is difficult to obtain geotag data in other places where there is a restriction imposed on data collection. These are the results and the conclusion. Coming to the questions which I wanted to ask Professor, can we extract valuable knowledge without using parallel computing approaches? Is the first question which I wanted to ask the professor. And coming to the second question, what type of algorithm techniques should be implemented in the future to get a reliable data? Coming into the existing algorithm techniques, what all algorithm techniques can be used? And thank you, Professor, for giving me the opportunity to record this video reading assignment 9. Thank you, TA, and thank you, class.